could be, well, this is green. This is green. This should be green. This should be yellow. This should be orange. This should be red, and this should be deep red. Can you do something with this color? Oh, yeah. Okay. Now, so you saw all the presentations with red colors. Okay, so we can start again, right? Okay, so we can get blue verdict, which means that there are not single modifications, not even those modifications which I showed you, not even kernel self modifications. Of course, this never occurs in the wild, but I just added for the completeness. Funny thing is that SVV gives you opportunity to disinfect system, and you can specify to which verdict level, to which level you would like to disinfect. So this is 0, and you can specify that you want to disinfect to level 0. So you can make your system 100% virgin, and it still works. I tried for several hours, and it worked like before. So green. Okay, this should be more green, but okay, this is green, let's say, and this is the most typical verdict, it means that the system is okay. Yellow, this is the innocent hooking detected, one of the hooking which I just described you. Orange, this is orange, not brown. But this is orange, and it means, well, less innocent hooking detected. In most cases, it means debugger like hooking detected. Those hooking with missing files, with missing files in system32 drivers directory. Red means it's very likely that we have something in the system, and deep red is, well, 99.9% that the system is compromised. Okay, can you switch to this? So let's start with some simple key. Yeah, I should have done it before because this laptop has only 500 megabytes, and this is really too not enough for me to achieve it. Hopefully, you will reach this state. Any questions in the meantime? Any questions? Maybe? Okay, so we have this is a system with Vanquish rootkit installed on it. Come on, maybe some questions. In the meantime, I need to change this font. And, well.
I have a quick question.
Okay.
So,
who are you? Where are you?
Hi.
Okay.
So, I think what you're doing, and I just want to try to understand a little better. I think what you're doing is you're going to run the system virginity verifier against a system that we're going to see as compromised. Is that right?
Yep.
So, can you tell us ahead of time what the results are going to be and what you're going to be able to restore to, or is that a part of that? I'm just trying to understand
what the results will be if I
exactly what level of compromise are you going to detect here as you're running the verifier in this instance?
What level I'm going to set the...
So you showed us the spectrum of the different colors for the different levels of compromise.
It will show on the command line. So
the command line will return the level of compromise?
Yeah.
Okay.
This is here we have one visual kit, and I will just change the font so you can better see it. And we will see, for example, red. Well, we see only the name, right? Because you know how to colors and text mode. So, well, maybe we don't know what is on the system. I can tell you in secret that here we have one visual kit. But we don't need to know it. We just run SVV. Can you hear? Can you see this? This is SVV check. right? So, yeah, it's really slow. Warming up, maybe see something why it's here. Now verifying all the modules, kernel and system DLS, and here is system infection level 5, deep red. Okay, we can now see some more details about it by putting /m switch, which will show the modifications. Oh, let's say this one. Modification at address 77E279. This is function enum services status. This function was obtained by reading export table. This is inside some module which is printed up. I don't want to scroll up. And jumping code was detected. Target address was 1AE something. This address is inside module. We don't know the name. There's no name for this module, which is in this range. And module file is not present. And I think it should be also hidden, but this time here. Let me see this. Here we see the CentOS kernel modifications, those modifications which we expect. You can see at every modification verdict level for this modification. This is 1111, so green. And then we see kernel 32. So we see some modification in kernel 32 driver, DLL, kernel 32, and we have modifications inside load library, create process. And this is a mistake of this output function here, because this should mark the file as hidden, not present, because it puts the verdict 5 here. But well, the logic worked well, so we have verdict 5. So the total system verdict is the maximum of the verdicts of the single little verdicts. Okay, maybe let's see another rootkit like Hacker Defender, which is the most advanced of them, and we'll see how disinfection works on this rootkit, just to save time. The person who asked me question just a few minutes ago. Does it answer your questions, or you still have some questions?
That makes it much clearer what's going on. I was just trying to get a little more on.
So do you talk to the Hacker Defender author?
Do they what?
Do you talk to, do you trade email with the
Oh, no, I didn't report this as a vulnerability or something like this. Okay, I need to change the phone, I'm sorry for this. So again, this system looks normal. Well, you need to believe me that it looks normal, because we don't have time to check if it looks normal. I'm sorry for this long answer. We don't have questions. Maybe somebody lost and wants some explanation. so again, we have a system, well, we don't know anything about it. So again, we will start this VB. Warming up is just a delay loop. It's because some rootkits is to give some rootkits time to infect the detector. Okay. Again, we have some infections in some system DLLs. Again, we have deep red, and again, let's see at the modifications. Again, we have enum service status function hooked. This is not a surprise because many rootkits are interested in hiding their own services, so we cannot see them in control panel services, right? So this is the function which is responsible for returning the services running on the computer. So many rootkits, simple rootkits, hook it, because more clever rootkits, well, does it in a different way. Again, we have a jumping code conducted here. Oh, we can. This is the expected code, and these are the bytes which were observed in the memory. E9, everybody who knows assembler knows what E9 is. Yes? Anybody knows what the E9 opcode is for? Hmm? No. Yep. It's a relative jump, as Dave said, and this is the relative offset, so this is the jump code, and this is the decoded target address, and this target offset doesn't belong to any module, which is innocent hooking type 3 or something like this, or 2, I don't remember, and this is obviously very suspicious, so we have deep red alert. So let's see how the disinfection process works here. Well, let's see. I'm not sure if I have Process Explorer on this machine. Yeah, okay. We have Process Explorer. Oh, we have services here. Hopefully you can see this. Well, there are nothing suspicious here. Let's run the disinfection process here. And we'll watch the Process Explorer with the disinfection. Are you sure? And now we see Hacker Defender appeared here. What SVP just did, it just restored all the code modifications which are marked as infection level 2 or more, and it restored it, so the functions are not hooked anymore. So Process Explorer now gets the real system view. Is it clear? And we can also go to the main directory, for example, and now we can see HITBSecConf directory, which was hidden before. Maybe I can show it to you. Yeah, it was. This is the directory I did at the just at the beginning. There was no HITBSecConf. After the disinfection process, everything is visible. And now, of course, to remove the rootkit from the system forever, we need some antivirus approach to scan the registry and remove the services also. Okay, let's see how SVV behaves on a clean system. Any questions? Yes?
So how is SVV actually fixing that? What calls are you making?
Well, SVP has client-server architecture. It has its own kernel agent. It has its own module in the kernel. This kernel restores the memory by just writing to the virtual memory because it's in ring 0, so we can write to the memory. Yeah. So the restoration process is consists of 3 phases. First phase is first stage is to restore kernel modules. Then we restore our own process modules, and we don't need any API for this because we can just unprotect the code section of our own process, and we can just write to the